Well, welcome to ATAR's webinar, everyone. It's leveraging predictive analytics to address climate change issues, which is from our predictive analytics working group. For everyone that doesn't know, ATAR stands for Advanced Technology Academic Research Center. It's a nonprofit that facilitates collaboration between government, industry, academia, in order to accelerate technology modernization initiatives. We provide ongoing opportunities for cross-agency collaboration through on-site interaction, learning, and market research. So welcome, everyone. Thank you for joining us today. Before we do begin, I want to encourage everyone in the audience to submit questions, if you have any, into the Q&A section of this platform, and we'll be going through them as they come in, and might be answering a few at the end. So please send them in as soon as you get them. But I would like to introduce our moderator for the day. Malia West is the CEO of Global Accounting and the industry chair for our Predictive Analytics Working Group. Malia, over to you.
If I can get off. Thank you, everybody, for joining this webinar with ATAR. I really appreciate everybody's questions. This will be a fun-filled, very impactful. We got some great experts. We have Ed from First Foundation, and we have Shakib from NTIS. And I want to first introduce Ed Kearns. He's a great expert in what we're talking about today and what we're going to be wrapping up in policy and some of our discussion. Ed, can you tell us a little bit about yourself?
Sure. Hey, yeah, my name is Dr. Ed Kearns. I'm the Chief Data Officer at a nonprofit called the First Street Foundation. Before I joined First Street about 2 years ago, I was a federal employee and was the Chief Data Officer at the Department of Commerce and Chief Data Officer at NOAA. So I'm a scientist by training. My PhD is in physical oceanography, been doing observations in climate for many years. Do you want me to talk about what First Street Foundation is now, too, Malia? Or
yes. Tell us what great work you guys do.
Well, most people are not familiar with First Street yet. So First Street Foundation is a 30-person nonprofit based in Brooklyn, New York. And we are dedicated to the quantification and communication of climate change at a very personal level. So we're trying to make climate change real and meaningful to the average American. And so what we do is we look at different kinds of hazards such as flood and wildfire and heat, and we produce products that help people understand what these are. So about a year and a half ago, we launched a flood risk product called floodfactor.com that many of you may have heard about that, or you may have seen it integrated into our partners at realtor.com or redfin.com. It basically gives property by property risk assessment now and 30 years in the future with climate change for flood risk. So we're taking that very kind of personal property by property hyper-local approach to climate risk today.
Great. You got some great work and some great insights on what our discussions today. Next, I want to talk about the fabulous Shakib and his work with NTIS. Shakib, can you tell us about yourself and what your NTIS is about?
Absolutely. Thank you for the opportunity. Good afternoon, everyone, and welcome. It's a pleasure to be here. I'm Shakib Shribi. I serve as Chief Data Scientist and Acting Associate Director for the Office of Data Services at NTIS, the National Technical Information Service. NTIS is actually a bureau within the US Department of Commerce. Ed and myself, we were actually colleagues. And we miss you, Ed, by the way. And so we are a bureau within the US Department of Commerce. We provide, we are really the best kept secret in government because we provide a unique pathway for federal agencies towards innovation and digital transformation. We offer an agile and an innovative framework in harnessing emerging and cutting-edge technology, including data analytics, artificial intelligence, machine learning, to achieve mission outcomes effectively and efficiently and deliver data-driven solution. We have a special authority from Congress that enable us to partner up with the nation's top private sector companies, academic institutions, and nonprofit to address national data-centric challenges. It's actually available to all federal agencies that's seeking an agile capacity to scale and quickly access to private sector ingenuity and expertise. Since we're going to be talking about the climate change, I would say that data is power, AI is the new electricity, and NTIS is the vehicle to empower federal agency to harness data science and related innovative and emerging technology to address data-centric national priority and achieve mission outcomes. So looking forward to the discussion. Thanks, Mario.
Yeah, great. So we're going to kind of jump into it. And I know that, I right now I'm in Portugal. For those people, the world is interconnected. And I know, knowing now that there's a lot of wildfires going on in Australia, United States, a lot of flooding here in Europe and in Southeast Asia. With that entails, there is a rise in methane and also in CO2. So methane is kind of that we can get rid of that over a decade, but it's 1%, and that chemical imbalance with that is very transformational. So what is kind of the challenges and issues surrounding climate change now, as you foresee it, and now we're seeing wildfires in California, Northwest Pacific, in Europe, a lot of the flooding. Kind of give me what you start seeing around that, Ed.
Yeah, so I think, one thing that I think is really started to change over the last 20 years, particularly it's kind of like the national government scale, particularly in the US, has been a change in the conversation from about like, is climate change happening? How do we know? Is it a scientific question? It's moving from that now to more of like, okay, how are we going to deal with it, right? So which is great. So it's nice to see the conversation get through all this. And now the challenge is not, hey, do we have enough science to understand if climate is changing? Now we're like, okay, we've got a lot of good measurements and a lot of good predictions now for climate change. Now it's not if or how, now it's how much, to whom, who's going to be affected, who's at risk, right? So to identify those areas that we have to concentrate on. And of course, I think in the short term, it's more about climate adaptation. How are we gonna get by this until, buy some time until we can address the bigger questions of carbon dioxide and methane that you just talked about, the greenhouse gases question. So I think it's now we're looking at, can we get specific enough with our understanding of how climate is changing to understand who is going to be most impacted?
Great. You have anything, Shakib? I know it's kind of, as an agency level.
Yeah, I think one factor that affects climate change, of course, it's our energy use. So I look at it from the data science and artificial intelligence perspective, and how can they contribute to that. So energy is a key source of economic growth. Because many production and consumption activities involve energy as a basic input. So what's happening here is that the consumption of energy and resources, we don't want to go back to the beginning of humanity, but even starting from pre-industrial era, the consumptions of energy in the world has been progressing exponentially. So water, energy, and environment are major challenges in our near future. So as an example, scientists have found out that in August 2021, just August last year, we have consumed 100% of the world renewable resources. So since then, we're creating a deficit, basically. So we're living with credit, and something that we cannot keep doing, because at some point there will be severe consequences. Like you said, we can talk about the effect of climate change currently, like in Bangladesh, for instance. You're a world traveler, Mario, so you can relate. Bangladesh is one of the countries that suffer the most from climate change because of a geographical location and history. Salinity in soil has increased by 26% over the past 35 years. What does it mean in real life? It's by 2050, 1 in every 7 person in Bangladesh will be displaced by climate change. So whenever we talk about climate change, we think about big disasters, etc. But in this case, you can see that it's the real effect on real people, socially, economically, and the personal life. Rural America, right here at home, has experienced a lot of impact of climate change related to weather effect, and that affect crop and livestock, and etc. So, and there is decline in water breaks, there is increase in heat, drought, etc. All that affect, of course, the livelihood of rural America, and have a serious impact on the nation in terms of economic security and national security. So all of these issues are there. And I'm glad that we have this to discuss a little bit of the solutions that AI and machine learning and data science can help with addressing those.
That's great. I know that the three biggest producers of climate change has been wastewater management, agricultural, and production of energy. What policies have you seen been very helpful understanding and predicting climate change, and how impactful are them? I know it's on a personal level. You go down to the individual. Can you tell us a little bit about what impact policy changes have? Because those three, given energy production, wastewater management, and agriculture, those can go down to the personal level. Can you tell us a little bit about that?
Yeah, it's certainly true, and I think this is getting to how can we understand this, and what and what policies we should take to address these. But to begin with, the sort of like the data policies that we have in the U.S. That allow for us to actually understand this. So, I guess it goes back to 2013 when it was a policy, the open data policy back in the Obama administration. It's since become law. So I guess it's beyond policy now. It is the rule of the land, the law of the land, in the U.S. government, that if the data can be shared, that they must be shared and shared openly, right? This is huge. Because it allows the analysis of taking the environmental data, combining it with the kind of economic data, socioeconomic data required to understand what the intersection is of physical change and economic change and population changes and stuff, right? And I think that, so I think at the heart of it, those data policies that have been established and laws that have been established give us a fighting chance to understand what we need to in order to start to take action, right? To implement other policies and take actions both as a nation and as local communities to start to address these kinds of things.
Yeah, I'm also seeing, you're hearing, anywhere between 3 to 5% temperature increase by the end of the decade. That's very, it's obtainable. But like Shakib said, you're getting into wastewater management and agricultural and things like that. What policies do you see, Shakib, going, from what you've seen in the data, or policy shifts?
Well, I'm not a climate scientist, so, but there is, of course, the international agreement that has been signed by more than 196 countries. The Paris Agreement, for instance, is a legally binding international treaty on climate change, and the goal is like you said, Mario, is to limit the global warming to below 2 by 2050. I mean, the problem is that how to put it in practice. So those policies are great on paper, but they have to be applied and monitored and controlled and funded. That most of the issue, a lot of issue, of course, of that is also funding, and of course to do more research to be more efficient with the funding that you have, and hopefully with artificial intelligence we can do that. Like you said, like the target is about 1.5%, but already people start talking about like we're going to be reaching 2.5, if not 3%, so 3 degrees above the target. So definitely we have a monitoring the task force targets are reached, etc. So we are here, and like you mentioned, Mario, there is so many industries that contribute to the pollution, etc., and that increase the issue. So it has to be a global approach at the international level, as well as at the national level and at the state level here in the US.
That's great. And I know that, you know, kind of going back, Ed, to what you were saying in an introduction and what your foundation does for some of these other housing markets and things like that. What measurements are you seeing, are you keeping track of? And what tracking tools are better for what you're foreseeing?
Yeah, so trying to come up with you know, an assessment of how the change is impacting, you know, we're taking the approach property by property, you know, house by house and business by business across the US. Because you have to, we believe you have to start at that level, and then you can aggregate up if you want to do kind of wider scale kind of analyses for policymaking and such. So of course we're dependent upon, you know, access to the climate model information and earth observing information, which in the US, again, since it's open data, it's pretty easy to get to. The climate models sometimes are hard to understand, and there's a whole bunch of, so there's a whole, you know, global climate change modeling community that has gotten together and taken an ensemble approach very similar to the kind of approach that we take for weather forecasting and hurricane forecasting these days. It's proven to be a very, very effective way of doing that. So having access to that information is absolutely crucial. And then getting the kind of access to the information that we need for that property specific stuff, that we normally get that from commercial partners that aggregate publicly available like tax assessor record data and stuff like that about people's homes and businesses and such like that. And we bringing those together, the intersection of those, merging those allows us to do kind of analysis that we want to. And then it's like, okay, well then once we have this information about what's going on at, you know, really high horizontal resolution, somewhere between 3 meters and 10 meters, you know, resolution across the US, then who can use this, right? So getting into the hands of the individuals is one thing we do, that what we do with like our realtor partners and such, right? We get that out there. We have a website, put that out there, but we also deliver those data in bulk to other partners. They can use them. And so, you know, we've signed a number of data sharing agreements with government agencies that are doing R&D on this kind of stuff. Everybody from HUD, FHFA to Federal Reserve Bank to EPA. You know, there's a long list of federal agencies that we've signed agreements with. And what we're hoping is that, you know, from their research and development, looking at that high resolution climate risk data, that they'll start to, you know, it'll start to evolve into decisions and actions that can start to address these things.
So it sounds like you guys are taking a ground up approach from you know, from micro to macro level. That's great to hear. So Shakib, what have you seen on, you know, you're one of the smartest guys I know, data scientist guy. What do you foresee, you know, in some of your tracking and better tracking tools and things like that?
I think what Ed said is really key. You know, the climate issues are complex. It's not a simple issue. So the more data you have, the better. But like Ed said, it has to be done at the granular level. So the climate models have helped us a lot. But we need to get a better understanding, better insight about what they collect and what's needed and what's not needed, etc. So usually what the typical measures that are usually collected in this context are the average surface temperature of the planet, right? So that's what we want to limit the warming to 1.5 degrees Celsius by 2050. We look at the level of carbon dioxide in the atmosphere. We look at the rising sea levels and the acidifying of the oceans. Let's not forget that the ocean have been absorbing carbon dioxide for since the mid 19th century, since the industrial era started. So that's a very serious problem. So, but like Ed said, it's all about collecting data that can complement the climate model with artificial intelligence, machine learning models, and then try to, and it's a process. Like you know, Mario, machine learning models are they use an iterative process and they get better and better. So data sharing agreement that Ed mentioned, and how to encourage collaboration between nonprofit organizations, the federal government, and the private sector are really key in terms of trying to measure the right stuff and try to get the right data on the right place at the right moment. So that's the goal that we should pursue and encourage.
That's really actually really great. In talking with, after we kind of introduced ourselves, I'm an advocate, ocean person, and dive master SSI, and I also help teach wounded warriors. And in happening, I'm starting to see some changes in not only environmentally scuba diving and on the reefs. What do you think is happening to climate change within the next 2 to 5 years? And what research and what assumptions do you think you see on the horizon? Shakib?
Sure. Well, I believe that as a data scientist, that AI is a game changer, because as you know, AI works. We don't follow a set of explicit or predefined rules. We aim to build systems that can learn and infer such rules based on patterns in the data. So if we are to meet the goal of limiting the increase in the average global temperature to 1.5 degrees Celsius, as specified in the Paris Agreement, we must reduce the CO2 emissions by 50% by the end of 2030. So very soon, and I believe that AI can help with that. Some studies have shown that with the use of AI, you can achieve 5 to 10% of that needed reduction. So it sounds like little, 5 to 10%, but it's enormous in terms of climate change and climate impact. So the potential of and effect of global climate change, as you mentioned at the beginning of this talk, Mario, include wildfires, period of drought, etc., in several places, and the work now is that we want to build the capabilities and the confidence that we have the models and the data to help us reducing the warming of the planet, and then try to avoid the devastating effect of that. So just to give you an example about use, for instance, of artificial intelligence in that fight is in terms, I can provide 2 examples, of course, in terms of energy as well as with disasters. So in energy, there is a lot of studies that involve AI, because AI allow you to, based on data, to give better prediction, better forecasting, as well as try to predict failures in the grid, etc. So that all that helps a lot in terms of not only preserving energy, but also whenever a failure occurs, to be on top of it and repair it quickly. So that saves a lot of energy. So with AI, you can actually handle power fluctuation and improve energy storage. The other example is, which I found fascinating, which is about Hurricane Maria that happened in the Caribbean in September 2017. So it's a devastating hurricane. And for instance, in Puerto Rico, NASA actually worked on a flyover there to try to see the impact of devastation of Hurricane Maria on the rainforest. So they basically took pictures, images of the area, and using a very high resolution photography. But once they got that information, in order to see which species of trees have actually been devastated and which one have survived, to be able to see the impact on the atmosphere about carbon dioxide, they use actually computer vision based on artificial intelligence. So they allow them to actually go look at the pictures and do that work, which is, if we do it at the human level, manual level, it will be really tedious. So this is kind of things that I see coming up very soon is in terms of leveraging AI capabilities in order to solve real problems.
That's great. I know that Ed has a really passion about the ocean and its impact, not only at the ocean level, in the community level. So what do you see within the next 2 to 5 years, and what assumptions research do you think you've seen, not only in your professional life and personal life, but also in what you do?
Yeah. So yeah, and so as a scientist, as an earth scientist, oceanographer, I tend to view the impact on the oceans and the land and the atmosphere, and as a scientist does. But one of the things that I've learned is that it's really important to be able to translate that view into other variables, other meaningful things that upon which decisions are going to be made. And so we've been spending a lot of time at First Street using the same kind of machine learning and AI methods as Shakib was just describing, but using them to also to fill data gaps and to make connections between those changes in CO2 and with temperature and precipitation, and tie them to the number one, time to dollars and cents, which is always hard to do, but that's the universal language, dollars and cents, but also into other things like where are populations going to be migrating as they're escaping kind of disasters like Maria? Where do these people go? When this is happening over 30, 40 years, how can we expect populations in the US and across the world start to move, right? What is it going to do to things like insurance rates? What's it going to do to, supply chains and agriculture? There's so many different aspects of fisheries, right? So there's a lot of research going on in that right now to try to get to the impacts. And one of the best things I've seen over the last 2 years is a shift in the thinking, particularly at the U.S. federal government level, right? Going back to George W. Bush with the U.S. Global Change Research Program, USGCRP, which did some great stuff. But ever since those days, like at the federal policy level, climate change has been kind of been viewed as a science project, right? We're still trying to find out the information. USGCRP is led by the scientific agencies, and so it's always like, oh, that's a NOAA, that's a NASA, that's a USGS problem. But over the last year in particular, we've seen a shift, right? And with this administration, they're actually leading with Treasury, right? They're not leading with a science agency. That is a huge shift in how climate change is being viewed, because now, Treasury has access to any federal government information that they want, but they're not earth scientists, right? They can't easily consume the climate models. They have as much difficulty as anybody else. They need that stuff translated into what Treasury deals with are things like populations and jobs and financial regulations, these kinds of things. And so that is starting to happen now. And that makes me very, very excited for what's going to be coming in the next couple of years, right? Because it's going to be, again, zeroing in on those impacts on populations, on business, on people's lives that were, and that's how things in this country, I think, are just going to have to, that's how this, the huge super tanker that is the US economy, right? How do you turn this thing? It's turned with things like with, government regulation is one of the levers that we've got in order to turn things towards, different kinds of energy use and different kinds of actions across the US economy that are going to help us, prepare and react to climate change.
That's very insightful, because, as Shakib, as you kind of alluded to, Bangladesh, Myanmar, aka Myanmar, and that economy, that Southeast Asia is a big economy. There's 2/3 of the world's population there, and you starting to see an impact, a shift in U.S. policy from into the Pacific realm, and wildfires are starting to come into effect. In predictive analytics and how to improve and address current and future issues, what are you seeing, Shakib, in some of the modeling and some of the, you kind of alluded to wildfires and things like that. What are you seeing in predictive analytics?
I think it's a great question, and I appreciate what Ed said also about the real impact on everyone's life. So it's not like some serial issue here that we're talking about. So, but to address your question, Mario, is that I think artificial intelligence and algorithms and predictive and machine learning analytics can offer a range of benefits. Because the first thing that we always need to do is to accurately measure the emission footprint. So we need to baseline. So and measure it accurately, and then we can set targets and act and repeat, of course, because that's how you learn with whenever you want to use machine learning algorithm. Of course, you need to answer a couple of questions. What are the features, the best feature that I should use? And what is the best algorithm for my data sets? And again, that's something that you need also time, iteration. So you can start the process, and that's where Ed mentioned the importance of data collection at the granular level, and then of course involving scientists in the field, the SMEs that know effectively what to measure, etc. And then use actually AI can help you also with that first step, which is very difficult, which is where are we now? And AI can help us measure the emission footprint, evaluate the impact, and then set the minimum target and successful action plan. Because then once you get all that data, you need to make some decisions. And again, you can use artificial intelligence to help you make the decision based on what you want, what your target is. AI can also help us develop innovative models that complement current models to address these issues. And so we can actually use AI to perform large scale, because it's a worldwide problem. Large scale carbon management in the soil at a low cost. So and then we can also improve the resiliency of our society to climate effect in the meantime. So not only at the power grid, but housing, etc. So all this is needs to, like Ed said, it's all about money. Of course, you need to fund all these resolutions and prepare us for the current effect, and hopefully in the long term we can actually address these issues.
That's interesting, because I'm kind of circling back what Ed was saying at a cost level. Treasury, everything, a lot of things are starting to become at the treasury, the U.S. Treasury, and we're kind of taking actions with predictive analytics. And you being a scientist, Ed, how can you think we can improve to address issues now and in the future?
Yeah, I think using this predictive analytics to go from the climate model ensembles that have been shown to, they have a certain amount of skill, and you bring them together in an ensemble method. They're very, very useful for looking out, 50, 100, 200 years even. We're really trying to focus in on the next 20 to 30 years in particular. But there needs to be a translation from these computer models are global scale, right? Because you have to model the entire Earth to understand the climate, right? So that's what we do as a community, and those things are necessarily very coarse, right? So they're the spacing in the models, hundreds of kilometers, really kind of coarse. But we need to take predictive analytics, use AI, machine learning to translate the forcings at those kind of scales down to, if it's a physical model, like for wildfire, one of the things we're doing here at First Street, we're taking those forcings to the level, and we're translating it down to what happens like at a 2-kilometer level, so that then we can take it again and go down to a 30-meter level on the landscape level in order to understand what the impacts are at this larger scale. How does that translate down to what's happening literally at your house, what's happening outside your house and on your property, right? The same thing for the financial models for Treasury and others, but they're going to be looking at is trying to do that same kind of predictive analytics to translate that climate model information, down to something that's going to be about markets or interest rates or what, you know, all the different things, where the best investments are, where the risk is, right? And you know it's really starting to take off when, you know, if you've been reading the paper over the last, you know, 6 months or a year, we've all seen that there's a whole bunch of climate services companies, to put it under that term, people that are doing exactly this kind of work, right? A lot of for-profits. We're nonprofits, so we're not going to get acquired, but there's a whole lot of other companies out there that have been acquired, right? And this is you know, it's great. This is, you know, this is how the business works and stuff too. But these larger companies have realized, wow, there's really a lot of value in these predictive analytics. They're finding the smaller companies, these little startups that are doing that, and they're buying them wholesale and bringing them inside the fold, inside their companies. So that's good. I mean, it shows where the value is. They're paying a lot of money for these companies, right? The bad thing is perhaps is that, you know, the information and skill that these companies have is now being kind of hidden from sight within these larger companies that are going to need to extract that value to understand, you know, for their businesses, and that's great. And so, you know, like at First Street, we're really thinking that, you know, one role that somebody has to play is somebody's got to democratize this information, put it out for everybody to see, right? And governments try to do this too. We're trying to do it from our seat as a nonprofit, trying to put this stuff out in public view so that everybody can understand, so that, you know, everybody has a fair chance of understanding how that climate change is impacting their little part of the world or their part of the economy or whatever they happen to be interested in. But that connection between those things, everything is predictive analytics.
You bring up some interesting points, you know, connecting one dot to another. There's going to be some comparably uncertainties, but Shakib, how can you think these uncertainties, how can predictive analytics can be helpful and convey to the end user?
Yeah, absolutely, Mario. Right. But I want to build up a little bit first on what Ed said, because that's really like key, very absolutely on point there. Is because in terms of sustainability management and decision making, the use of AI has been very limited, and that's unfortunate because most of the work relied on models that examine single dimensions of land use or climate risk, etc. So what Ed was stressing is that there is a need of a more comprehensive approach, and not only at the granular level, but a comprehensive global as well. That we need to develop models that actually can learn from diverse data streams and transfer that learning to us for decision making. And as we know, the great strength of AI and predictive analytics lies in its ability to learn by experience. So collecting massive amount of data from their environment and making the connection, like you mentioned, Mario, that sometimes us humans fail to do or notice, and make the appropriate actions on the basis of those conclusions. But whenever you develop a model at that point, it's you know, machine learning models are probabilistic models, so there's going to be some uncertainty that we need to address. And I have to say very quickly that this is something that we have to learn to work with, because that's part of the model. The question is that how can we, what can we do to try to diminish or minimize the uncertainty? And technically, there is different ways that you can do it with the machine learning models. You can use, of course, different types of models. So, since you can use Bayesian theory to do that, etc. That allow you to help uncertainty, or you can keep running the model with additional data, more quality data, to help you reduce the uncertainty. But uncertainty in applied machine learning is managed using probability. So that's the bottom line there. There's going to be some noise. There's going to be some uncertainty that we need to handle and quantify. But we can calibrate our model. We can use different probabilistic approach to address that, and then use additional data from outside as well, and include even synthetic data to develop a better confidence in our model, in our predictions.
and you know, there's a lot of predictive analytics, and there's different ways to hash it out in science, and you know, in predicting sometimes uncertainties on some of these new models. How can you convey that uncertainty to users?
Yeah, that's one of the holy grails, I guess, of science, right? Is being able to convey uncertainty in a certain way that's understandable. And I think, frankly, as scientists, I think we often make the mistake of you know, when we talk about uncertainty in the sciences or in machine learning, it has a very good definition, right? And we'll say things like, oh yeah, you know, we're 95% certain. If I get a 95%, you know, certainty in my analysis, hey, as a scientist, I'm going to be like I'm betting the house on that one, right? But if I say, you know, it's within the 95% uncertainty limits to, I don't know, a congressman or, you know, a reporter from a newspaper, they're thinking, oh, so 5%, you're really not sure. There's still doubt in your mind, right? It's like, no, that's not what we're trying to convey at all, right? So I think we're using the same word uncertainty, but it's being lost in translation in the middle. So I think doing things like having very practical measures of uncertainty, like demonstrating like the upper and lower ranges of what this would mean, you know, translating it through those functions we were just talking about, to, you know, bringing it down to dollars and cents or other meaningful metrics of climate change, to demonstrate what the possible range is based upon you know, the scientific uncertainty. How does that translate into a decision-making uncertainty in the real world, right? Because like if you knew that, hey, there's a 75 to 95% chance that your house is going to flood within 5 years, are you going to be bickering over that 15%, or are you going to just go get some flood insurance, or maybe see how you can raise your house, or maybe you're going to move, right? So that 15% uncertainty is not really meaningful in the real world. It's just like that's a level of uncertainty that you're just not going to be willing to live with, right? So I think we have to be, you know, as scientists, we have to be kind of on our toes to make sure that when we're talking about uncertainty, that we translate it as well as we're, you know, to something that can really convey what the, you know, what the touchy-feely, you know, in the gut of your stomach kind of feeling for whether that is a meaningful uncertainty or not for the user.
Yeah, statistically in correlation, there's a lot of, you know, simulations between the cost of doing business and correlation between climate change and the cost of doing business in coastal areas. I want to thank you guys. You guys, you know, showed and taught me a lot of great things and about climate change, and you know how it goes from a macro level down to the micro level, and you know, I want to thank you guys for helping with the panel.
Very welcome.
Awesome. Well, thank you everyone for joining. Unfortunately, that is the end of the webinar. Thank you, panelists. You guys did an amazing job, and Molly, of course, for moderating. I hope to see you all at ATARC's next event, and everyone have a great rest of your day. Bye, everyone.
Thank you, everyone. Bye-bye.
Thank you.